Today we are going to be talking about polynomial and rational inequalities. By the end of this video, you should be able to solve polynomial inequalities and rational inequalities. First, a few steps for solving polynomial and rational inequalities. You need to first get the inequality equal to 0. And I know when I say equal, I don't actually mean an equal sign. It's still an inequality. We are still going to have inequality symbols. But you need to get everything on one side of the inequality. Then you need to find all zeros and excluded values. Zeros, I mean where it equals 0. Excluded values, I mean asymptotes or holes or removable discontinuities. Then you're going to use these numbers to create a number line and test a value in each interval to determine if the function is positive or negative. So, let's take a look at our first example. We have x squared is less than 4x plus 12. So, much like we would do if this were an equation, we want to get everything to one side. Then we want to factor. Here's where equations and inequalities differ. If this were just an equation, I would say, all right, x minus 6 equals 0, x plus 2 equals 0, so x equals 6 and negative 2. I can't do that with inequalities. I can't just say, well, x minus 6 is less than 0, so x is less than 6. X plus 2 is less than 0, so x is less than negative 2. Doesn't work that way. Our zeros are 6 and negative 2. Our excluded values, well, this is a polynomial, so there are no excluded values. Now I want to make a number line and use my zeros and excluded values. So now, I'm going to pick a number in each of these intervals. For this middle interval, I'm probably going to pick 0. You can pick anything that's greater than 6. I'm going to pick 10. Pick anything that's less than negative 2. I'm going to pick negative 10. And you want to plug each of those three numbers in red into our polynomial and see, do we get a positive answer or a negative answer? So if I plug in 0, that'll give me negative 12, which is clearly negative. If I plug in 10, well, the thing is, I don't care what number it is. I just care if it's positive or negative. So a shortcut to doing this is if you take 10, you plug it in here. 10 minus 6 is going to be a positive number. 10 plus 2 is going to be a positive number. Positive times positive is a positive. So this is going to be some kind of positive number. I don't really care what number it actually is. Then I'm going to do the same thing with negative 10. If I plug in negative 10 here, negative 10 minus 6 is going to give me a negative answer. Negative 10 plus 2 is a negative answer. Negative times a negative is a positive. If you don't like that shortcut, then by all means, go ahead and plug those numbers into the quadratic x squared minus 4x minus 12, or into the factored version, x minus 6 times x plus 2, and get an actual number. So, we wanted to know where this was less than 0, or where it's negative. So that happens to be between negative 2 and 6. But you need to pay attention to the symbol. since this is strictly less than, not less than or equal to, we are not including these 2 points. We just want the interval -2 to 6, not including -2 and 6. So that's the basic idea for solving a polynomial or rational inequality. Let's look at a couple more examples. Here we have x to the 4th is greater than or equal to 8x. I need to get everything on one side, and then I can factor. So if I factor out a GCF, then if you remember from Algebra 2, x cubed minus 8 is the difference of perfect cubes, and there is a specific pattern for factoring. Now that we have it completely factored, we can write out our zeros and excluded values. If we set each of these factors equal to 0 and solve, we could get x equals 0, x equals 2. This gives us complex solutions. So we don't care about that. Now that we're completely factored, we can go ahead and find the zeros. So if I set each of these factors equal to 0, I'd get x equals 0, x equals 2. This would give me complex solutions, which I don't care about right now. Excluded values, well, it's a polynomial, so there are none. So if we draw out our number line, put our zeros and excluded values on here, then we need to pick a number in each of these intervals and plug it into our equation so we can see if we have a positive or negative solution. Well, I'm going to use this part when I mentally go back and plug it in. If I plug in -10, I have negative number here. A negative cubed is a negative. I'm going to use this version of my inequality when I go back and plug things in mentally. So I have -10 times negative cubed is a negative. That's definitely going to be a negative. So I have a negative times a negative, which is positive. If I plug in 1, I have positive. 1 minus 8 is negative. So positive times a negative is negative. If I plug in 10, I have positive, a real big positive number, minus a little number. So positive times a positive is positive. Again, if you need to actually plug the numbers in, go right ahead, but you don't have to. We want to know where this inequality is greater than or equal to 0. So we want the positive sections. Since it's greater than or equal to, we are going to include 0 and 2. So our final answer is -infinity to 0 and 2 to infinity, with brackets on 0 and 2 because they are included. Now let's take a look at rational inequalities. Same basic idea. This one already has everything on one side. It's already factored for us. So we just need to look at it and say what the zeros are and what the excluded values are. Well, the zeros are just like the x-intercepts of the graph. We want to look at where the numerator is equal to 0. The excluded values are like the asymptotes. So where the denominator is equal to 0, then we make our number line. Since 1 is an excluded value, it's actually the vertical asymptote, we know that we can never include 1 in our answer because this particular rational function is not defined at 1. So I'm going to put an X through it so I don't forget about that. Now let's pick numbers and test our intervals. Okay, so I'm going to show you this shortcut again. If I choose -10 and I look at this first factor, that's going to give me a negative. Here I have 2 minus -10 or 2 plus 10, which is a positive. So negative times a positive is a negative. Here, anything squared is positive. So I have a negative divided by a positive, which is negative. Next, if I plug in 0, I'm going to have positive times a positive over a positive. Well, that's positive. 1.5 might be a little bit trickier to think about, but this would be positive, positive, always positive. And then 10 would be positive, negative, positive, so that's negative. Again, if you want to plug in the actual values, go right ahead. We are looking for where this is greater than 0, so we want the positive chunks. Since it is strictly greater than, not greater than or equal to, we are not including -3 and 2. And we already said we will never include 1 because that is an excluded value. The function is not defined at x equals 1. So our solution is -3 to 1 and 1 to 2. Last problem. We need to start by moving everything to one side. Now here's the important part. We need this to be one fraction. So I'm going to have to get a common denominator and add these together. So I need to multiply this -3 by x plus 2 over x plus 2. So I'll have 4x plus 5 minus 3x minus 6 all over x plus 2. And then combine like terms. So now I'm just looking at x minus 1 over x plus 2 is greater than or equal to 0. My zeros are where the numerator is equal to 0, which is just 1. And my excluded values where the denominator equals 0, which is -2. So now I can make my number line. Since -2 was an excluded value, that means there's a vertical asymptote there. So I'm going to put an X through that so I don't forget. Then I need to pick numbers to test my intervals. Again, I'm going to do this shortcut. If I plug negative 10 into the numerator, I'm going to get a negative, and into the denominator is also a negative. So negative divided by a negative is positive. If I plug in 0, I'm going to get negative 1 over 2, which is negative. If I plug in positive 10, I get positive over positive, which is positive. I want to know where this rational function is greater than or equal to 0. So I'm going to go ahead and include 1. I cannot include negative 2 because that is an excluded value. But I do want these positive sections. So my final answer is from negative infinity to negative 2, not including negative 2, and 1 to infinity, but I am including 1.